When a fire sprinkler system is installed in a building, it provides the greatest fire protection for occupants, contents, and the building itself. A building protection program that includes the inspection, testing, and maintenance of the fire sprinkler systems is vital to keeping the system properly working. Fire sprinklers provide important fire protection and safety in buildings of all types, including multifamily residences, commercial buildings, industrial buildings, high-rises, and more. They control or extinguish a fire while it's still small, allowing occupants extra time and a passageway to safely escape. However, just like any other system in a building, a fire sprinkler system must be properly inspected, tested, and maintained to ensure it works in the event of a fire. NFPA 25 is the standard for the inspection, testing, and maintenance of water-based fire protection systems. Compliance with the standard maintains system integrity and avoids failures, ensuring a reasonable degree of protection for life and property through minimum inspection, testing, and maintenance. NFPA 25 establishes the minimum requirements for the regular inspection, testing, and maintenance, otherwise known as ITM, of water-based fire protection systems. It determines the actions needed when changes in occupancy, use, process, materials, hazard, or water supply that could potentially impact the performance of the systems are planned or identified. Inspection is defined as a visual examination of a system or portion thereof to verify that it appears to be in operating condition and is free of physical damage. A test is defined as the operation of a device to verify that it is functioning correctly, or the measurement of a system characteristic to determine if it meets requirements. Maintenance is defined as work performed to keep equipment operable in water-based fire protection systems. There are 4 major types of fire sprinkler systems: wet pipe, dry pipe, pre-action, and deluge. Most people are familiar with wet pipe fire sprinkler systems, in which automatic sprinklers are part of a piping system containing water that is connected to a water supply. The heat from a fire individually activates the fuse or bulb in a fire sprinkler, which causes water to flow immediately. Dry pipe fire sprinkler systems have automatic sprinklers that are part of a piping system containing air or nitrogen under pressure. The heat from a fire individually activates the fuse or bulb in a fire sprinkler, causing a release of air pressure. That in turn permits the pressure from the water supply to open the dry valve. Water then flows into the piping and out the activated sprinkler. Pre-action sprinkler systems have automatic sprinklers that are part of a piping system containing air that might or might not be under pressure, with a supplemental flame, heat, or smoke detection system installed in the same areas as the sprinklers. 2 separate events must occur for fire sprinkler activation. First, the detection system must identify a fire and open the pre-action valve, which allows water to flow into the pipes. Then, a fire sprinkler must activate to flow water on the fire. In the case of a double interlock pre-action system, to avoid unintentional detector operation, the pre-action valve will not open and flow water into the pipes until both events occur. Deluge sprinkler systems, which are intended for high-hazard areas, contain sprinklers or nozzles that are already open. They are part of a piping system that is connected to a water supply through a valve that is opened by the operation of a detection system installed in the same areas as the sprinklers or nozzles. When the detection system signals the deluge valve to open, water enters the piping system and flows from all sprinklers or nozzles at once. Note, in pre-action and deluge systems, the ITM of the electrical components of the automatic fire detection equipment used to activate the sprinkler system are not addressed by NFPA 25, but instead addressed within the NFPA 72 standard. In those cases, the NFPA 25 and NFPA 72 standards must be coordinated to ensure the system operates as intended. Components that must be inspected include sprinklers, piping, hangers and braces, pressure gauges, and alarm devices. Sprinklers, pressure gauges, and alarm devices are components that must be tested. Valves, valve components, and trim must be inspected, tested, and maintained. ITM must also be applied to water control valves, alarm and check valves, pre-action and deluge valves, dry valves, hose valves, pressure-reducing valves, and backflow prevention devices. When conducting ITM, there are 3 types of issues you may see in a system: impairments, critical deficiencies, and non-critical deficiencies. An impairment is defined as a condition where a fire protection system or portion thereof is out of order, and the condition can result in the system or unit not functioning during a fire. An emergency impairment is due to an unplanned occurrence or was discovered during ITM activities, whereas a pre-planned impairment is due to work planned in advance, such as revisions to water supply or sprinkler system piping. According to the National Fire Protection Association, when fire sprinklers fail to operate, the cause was most often due to the system being shut off, typically a valve that was manually closed in the course of routine inspection and maintenance, but had not been reopened. A deficiency is defined as a condition that will or has the potential to adversely impact the performance of a fire protection system or portion thereof, but does not rise to the level of an impairment. There are two types of deficiencies. A critical deficiency can have a material effect on the ability of the system or unit to function as intended during a fire if it is not corrected. A fire sprinkler that is corroded or has been painted over would be considered a critical deficiency. Its spray pattern could be adversely affected, or it may not even work properly in the event of a fire. A non-critical deficiency does not have a material effect on the ability of the system or unit to function during a fire, but correction is needed to meet the requirements of NFPA 25. An example of a non-critical deficiency would be incomplete testing documentation or missing tests for a building. NFPA 25 ensures your occupants' contents in building are protected. Be sure you have a building protection program that includes the inspection, testing, and maintenance of fire sprinklers. Please visit firesprinklertesting.org for more information.